Good evening, everyone. It's my pleasure to receive you here today. We're going to start our presentation, our announcements, and then we're going to move into our dinner presentation. For those of you who come here for the first time, welcome to the South Texas section with AICHE, the American Institute of Chemical Engineers. I am Carlos Salamanca. I'm the current chair for this year, and I welcome you to our series of presentations for 2018. This is our agenda for tonight. We already started with some workshops, then our networking session, then we're having our dinner. These are the announcements. Then we're going to have another break, and then we're going to start having the main speaker. One of the things that makes South Texas section unique is the proactive ability of their volunteers. Without these volunteers, we wouldn't be able to deliver the quality of product that we usually have every single year. I'm going to start introducing our board, the executive committee. Our vice president is Tom Rem. Our secretary is Deborah McCall. Treasurer, Yurika Villalobos. Our past chair, David Rosenthal. Our position 1 for education is Sanjay Sharma. Our position number 2 for outreach is Sheena Reeves. Our position 3 for communications is Aniket Patankar. Position number 4 for human resources, Jimmy Kumanen. Our young professional chair, Swarup Bade. Our registered corporate agent, Matt Kolotny. Please help me welcome our board for 2018 with a round of applause. Our speaker tonight is someone very special, very close to the South Texas section. Is Jack Chosnick. He's going to present his talk about chemical engineering and, by the way, process safety. I'm going to introduce him later on, but this is going to be our main speaker. We already have a couple of workshops. Some of you attended those. We appreciate the presence of Dimitrios Georgis with his presentation about the next generation of process modeling and optimization technology. We also want to thank Arun Murugan with Filtering. He presented process safety and human factors using a context-aware operations management system. Now I'm going to introduce some of the events that we're going to have through the year. We're going to have different sessions. Usually we meet the first Thursday of every month. We're having a break during the summertime. And we're going to have this location, the Bugambillas. We also are going to have another location in the east part of town. We used to go to Brady's Landing. Unfortunately, due to Harvey, they got flooded. So we are going to try another place, which is the Battleground Golf Course, which is we are going to have the dinner February 1st. Then we are going to have different dinners through the year, and you are welcome to come to any of those. We are looking always for participation from the community, for the industry, for the volunteers. One of the volunteer participation that we ask is be a sponsor a meeting, sponsor one of our events, and it's a good opportunity for the companies in case your company wants to participate in a sponsor one of the dinners. Talk to us. We have many opportunities for that. In the past, we have 3 categories. We are going to continue with those. Is the bronze, silver, and gold. Each one of them, they have their own categories. There is more information on our website, so feel free to go and please let us know if your company is interested in sponsoring one of the meetings. Some of the sponsors that we have last year are their logos are displayed on this slide. Very good, solid companies, and we are really looking forward to see more participation in the upcoming events. 2018 marks a singular milestone. It's the 75th anniversary for AICHE. Between 1942 and 1943, a group of engineers here locally in Houston, they started the chapter. They started the chapter, they associated the chapter, and many things have gone through a lot of water has been going through under the bridge. And in part of this local section, the South Texas section, is very important because we have our predecessors have contributed to the development of Houston and making Houston the capital energy of the world. So stay tuned up because we are going to have some activities and some meetings about this milestone that we are accomplishing this year. You guys have seen, I want to thank Trevor Rice. He's our audiovisual person tonight. Also Carol Smith. They are very active in setting up all the different communications for our meetings. We have presence in YouTube, so in case one of your colleagues missed this presentation, it's going to be available via YouTube, and you can feel free to visit that presentation at any time. We have over 30 videos in the library, and it's a good presence. By the way, we also have a social media presence in Facebook, LinkedIn, Twitter. So feel free to sign up, like us, so that way you receive all the notifications very on the proper way. I would like to advertise the Season Pass. Season Pass is an initiative that we started like 3 or 4 years ago, and it involves a single payment for the combo for all the different meetings that we have through the year. It's very convenient in the price, very convenient in the way that you don't need to be registered to come. You can come at any time. In case you are not able to come to one of the meetings, you can send someone on your behalf. It could be a colleague, or in some other occasion you can bring a guest to one of the meetings. So far we have 32 people sign up for this Season Pass, which really is really great. And we are welcoming many more. So in case you are interested, if you were not registered for this event, the price is $149. For the future meetings, it's going to be $131. We are only offering this until February. So if you are interested, let us know. Let Yurika know about that. To mark our appreciation to our speakers, our sponsors, and our volunteers, we offered a dinner last December where we got together and celebrated this participation of our direct contributors to the South Texas section. I would like to call our education person, our education director, Sanjay, who's going to provide us with more information about the different opportunities that we have now with the local section.
Thank you, Carlos. Thank you, Carlos. First of all, I want to take this opportunity to thank the speakers for the workshops. We really are fortunate that in our section we have so many talented and experienced individuals who can share their knowledge with our other members of the section. Talking about the workshop, there is a sign-up sheet in each one of the workshop. If you didn't sign up, and if you need the PDF certificates, please, the sheets are still available at the front desk, and you can sign up your name, email address, and phone number, and we will try to get you the PDF certificate within a week. Second thing, I also want to take the opportunity, let me see. I want to take the opportunity to mention that if you are interested in conducting any of the workshop, please feel free to reach out to me, and I will see what we can do to arrange a workshop where you can lead and share your experience with fellow chemies in the section. In December, we had a session where we tried it for the first time last year, we had 3 workshops in a series. And each one of the workshops followed, and there was no other meeting. And I really appreciated the 3 speakers who took the time. And I thought it was a great way for the attendees to attend all of the workshop, because sometimes I get a comment when we have 2 parallel workshops going on. It's difficult, and all the topics are so interesting. It's just difficult to attend all of the workshops. So we started it last year, and I think we will continue doing it this year as well. We'll try to organize one where all the workshops are held in series. So with that, I think, Carlos, I'll let you take on. Thank you.
Thank you, Sanjay. Now I would like to call Dale. If you could please introduce another of our education events, one of the major ones.
Thank you, Carlos. Yeah, I'd like to announce that we are going to again have a spring PE review course starting on February 2nd. Several of you may not be aware that the PE exam has changed this year compared to what it has been in the past. It's no longer tied to a fixed schedule. You can come and take the exam anytime you want to get it scheduled at a Pearson Exam Center. And they've also changed it so that you don't take in any reference materials. You now have to use their supplied reference materials for the exam. So it's really going to change things. And we will be offering the course again starting on February 2nd over at the U of H. And we have some very talented volunteers who have been teaching the course for several years, and some new people have come in to help teach the class. And the registration deadline is up through next Friday. So if you've got a chance you're interested in taking the exam, we'd love to have you come join us over at the University of Houston on Friday afternoons. Thank you.
Thank you, Dale. Now, I would like to call our K-12 outreach leader. So please, Matt, you could please come and give us introduction about the different activities.
Well, thank you. This Saturday, as you see in the upper right-hand corner, that's the Engineers Council of Houston is having their annual retreat. It's a half-day event, Saturday morning, and it's an umbrella organization of organizations such as AICHE, STS, and it's going to be at the Houston Museum of Natural Science. The main speaker is going to be Jeff Lindner. He's the Emergency Program Director and meteorologist for Harris County Flood District, and he's also a great speaker, and he was kind of like a local celebrity after Hurricane Harvey. He gives excellent talks. We're also having Heather Dumyan, who's the Executive Director of the Science and Engineering Fair of Houston. And if anybody wants to come, ECH encourages multiple people from each organization to come and network and trade ideas with each other. It's 3.5 hours. It's free admission, free breakfast, and free nearby parking, public parking. And if you'd like to attend, either you can call Sue Pritchett if you get one of these, or you can, I think we also have one of these in the newsletter, or you can call me. And then the Science and Engineering Fair of Houston is going to be Saturday, February 24th at University of Houston. And we're looking for about 15 volunteers to be judges for the AICHE Special Award. Or if you prefer, you can be a place award judge for the science fair itself. If you're interested in either of those or would like further information about them, feel free to give me a call. And let's see, and then that's, in the morning, and then at noon there's going to be, have a get-together, the AICHE judges for lunch, and you can kind of trade war stories about your morning. And, well, actually, as most of us find it pleasant. And then we have a couple of other things later on. So if you have any, or if you have any ideas about K-12 outreach, any events you'd like me to know about, my name is in the newsletter several places. Just send me an email or call me. Thanks.
Thank you, Matt. It's really interesting what usually we can reach through for the K through 12 young people, because sometimes we kind of lead this inspiration that they need to pursue careers in science, technology, and engineering. Now, I would like to check something that we recently started doing, is the community outreach. We have been joining with different professional organizations to help. Last year we were very active, helping some of the victims of the Hurricane Storm Harvey here in Houston. Recently we went and visited the Beacon with the Society of Petroleum Engineers, SPE. We have an activity with them, and we are looking forward for more activities with other organizations. In case you want to participate, we always encourage people. You want to serve the community, you want to go along with your significant other, your family members, everybody's welcome. So looking forward to seeing many of you there. One of the activities that we have this weekend is going to be at the Houston Marathon. The Chevron Houston Marathon is going to be on Sunday, and we are going to be helping some of the runners to get some refreshments at the end of the race. For those of you who are members in transition, the South Texas section is a really great opportunity for networking, and we have implemented some of these programs. Two of these programs, the leader has been Tom Rem, and we have some volunteers who have been very active in the past, like Deborah McCall, now we have Fabian Solberg, who is directing two different activities. One is the networking lunch, which is in the west part of town at the Opni Hotel, on the first Friday of every month. We are going to have one tomorrow at this location. The other one is on the east part of town in the La Porte, Texas. It's called the Process Tech Network Forum. In case you guys want to participate, or if you have one of your colleagues or a friend who wants to participate in those, send them over. We usually have a very high turnout during these meetings, and they have very good topics. The topic for tomorrow is going to be about starting your own small business. There is an organization called SCORE here, and how they mentor and lead the process of setting up your small business, in case you guys want to set up something like that. I would like to call Young Professionals Group. Our Young Professional Chair for this year is Swarup Bade. If you could please come up and have the announcements for the group.
Good evening, everyone. First of all, I would like to congratulate all the new team who's taking the leadership in keeping the group going. Anyway, it's a great gathering this evening. I showed up this evening, and Carlos was asking me, have you ever attended Toastmasters? I said, yes, why? So you have to give an impromptu speech today, so that be prepared for that. So that's what he's testing my Toastmaster skills today. Anyways, young professionals, what is it all about? So I'm the YP chair leading the young group of professionals who are the next gen people who will be sitting after 50 years or in these chairs, actually. So recently, a couple of European kids, actually, I mean, they're from Europe, they're still kids, but they just came to our office to inspire the chemical engineering form, basically. So one of the kids was asking, like, why did you even pick chemical engineering? I was actually thinking, I never had a story, but luckily I made one now. So it was actually, it was a real story. So in 1997, actually, my uncle used to work, he's still working there, but he works for a HPCL refinery, Hindustan Petroleum Chemical Engineer Limited. But over there was an incident in 1997 which killed 22 people. Luckily, he was not on the shift, but he felt really bad for a couple of months because a couple of his friends passed away in that event. I didn't really understand, because I was in 8th grade at that time, why it happened, what happened really, but I could really feel his sadness in what his feelings towards his friends. But now I can feel proud saying that, okay, I work in process safety, I'm a senior process safety consultant, I could design some relief valves to protect your equipment from blowing up, or maybe create some safety measures to prevent all these safety incidents not from happening. Anyways, everybody has their own story. And the first time she was asking like how it feels like entering into these scary plants. I said, like, have you watched Narnia movie? Yes, yeah. So it's just the same feeling. Once you enter the door, you'll see the lines, everything talking to you the same way we see the pumps, exchanges talking to you. Where have you been all these days studying in the books? We are still running over here all the time, 24/7. So that's about it. Anyways, long story cut short, I'll be leading the young professional team this year. So all the activities which they have mentioned so far, I'll be getting the the volunteers, basically. We have a lot of YP programs, and we start with the K-12, like the students, and we even go to a lot of universities, the Prairie View, Rice University, University of Houston, A&M. We pick the next-gen chemical engineers over there, and we have a lot of networking events. Not the lunch, we have happy hours, So one of my friends was asking the other day, if I come to the happy hour, will I get a job? I said, I'm not sure about that, but you'll definitely get a drink, and you're lucky enough, you'll get drunk. So, of course, you'll find a lot of people who have jobs over there, so probably you might do a lot of networking too. We have a lot of networking events. We have a lot of plant tours going on. There are a lot of activities for young professionals. We have the E-Week event going next month, and we have our Young Engineer Award. We have a nominee for our group, STS-AIChE, which would be Morgan Reed. May I ask Morgan Reed to stand up? I would appreciate if you can give a round of applause for him. He works with Exponent, and he's been a very active participant, and he was the person last year at this podium doing the same presentation. He is the past YP chair. And coming to the Young Professional of the Month, may I ask Eureka to stand up? So, she's also the treasurer for the South Texas chapter. So when Carlos asked me, do you have any nominations for young professional? I said, I need to find who deals the money. So I found her. So make sure I get all the budget for all our events. Anyways, I would encourage everyone to be a part of the STS-AIChE family. And we have a raffle going on for the E-Week. This is for a rocket suite for 14 people. It's really good one. It costs $20 per ticket, and we have a discount for multiple tickets too. I would appreciate if you can purchase a couple of rackets. I'll make sure you get your ticket picked up. That's the same promise for everyone. Anyways, thank you for giving me this opportunity, and I feel privileged to be a part of this family. Thank you.
Thank you, Swaroop. Now I would like to talk about one of the major events in Houston. It's the Offshore Technology Conference. For this event, we prepared months in advance. This year, we're going to have the leadership as every year from Tom Men. Tom Men is recruiting volunteers. In case you are interested, you can go to the OTSIM. And the good thing about volunteering is that you are going to receive a free pass parking. You're going to get, as Tom mentioned, a lot of goodies, a lot of junk that you can carry away. And the option to attend the technical sessions is really good. It's a really good experience. In case you haven't been there, it's one of the major oil events I guess in the world. Not only for attendance, because also for the quality of speakers that you find in this place. Also, as South Texas section, we prepare something very particular. There is a session for teachers and students, and we provide some of the bags for these students and teachers. Usually, we will put in this bag things that are made by chemical engineers, things related to our different processes and products that we are able to produce. For this particular, we are asking, in case your company wants to volunteer or support this idea, have some goodies donated to our effort. So we can put those goodies into the bags. That way it goes to teachers, and these teachers are going to teach the students how to take classes in our field, in engineering. Also, we are going to have this year, I forgot to mention, the OTC is going to turn 50 years old, and it's going to be in the first week of May, in case you want to make arrangements to attend. Also, we are going to have another event from the same family. It's the Arctic Technology Conference. AIChE is very active. We have a committee working on that, and we are looking for people who wants to participate in this committee. There is no experience necessary. The only requirement that we ask is a very active participation to grade papers and to participate in the meetings. You can get to participate as a chair on one of the technical sessions. So in case you are interested, let me know after the meeting, or through an email, through my personal email. Now I would like to call Tom Mann for the section on awards. No, you don't want to come? Okay. Okay, Tom is the the leader for the awards nominee group. And we are, this is nomination time. We are going to have these nominations. They are going to run and be accepted through May the 1st. And it includes the Best Applied Paper Award, the Best Fundamental Paper Award, the Best in Practice Paper Award, which is new, the Outstanding Young Professional, it needs to be under 35, the Distinguished Service Award, and the Special Service Award. In case you want to nominate someone, let him know. There is a group of people who are very active: Matt Christensen, Tom Mann, and Ryan Stephens. Send an email to these people or talk to us, so that way we can forward that information to this group of fine group of gentlemen. Now we're going to call a couple of people who were very active last year. One of them is Morgan Reed, who did an outstanding job. Morgan, if you could please come up here. We're going to give you an appreciation plaque for the service that you provided us with the Young Professionals Group. Thank you, George Morgan. The other one is our past chair, David Rosenthal. He excused himself. He's on a business traveling and doing some consulting group up in the north of the country. So he did also a sensational and awesome job. Thank you, David, for your participation. As we have mentioned before, there are other opportunities to participate with the local section. One of them is be a volunteer, be a leader. We are usually looking for fresh blood, new people. And we encourage you to come here. It is a great opportunity, especially for the young professionals. We want you to develop those soft skills that probably you don't get to learn at work. And here you become a leader. You become a person who helps the community. And that's what we are doing. We are trying to raise the bar. We are trying to lift the spirit of the chemical engineering in the South Texas section. Sometimes we found a lot of challenges. We have members who are in transition, maybe recent graduates who don't find a job because they lack of the experience. So we are trying to provide the skills or provide the opportunities for those people who are really struggling in the chemical engineering community to improve, to be better. Another opportunity for volunteer is as a company, if you can provide or facilitate at your location one of the meetings that we have every month, let us know. We need a space for about 400 people, space for the workshops, ability to provide dinner, and convenient and free parking. Let us know in case your company is interested in that. I think that's it for now. We're going to take a break. If in case you guys want to leave early, please don't forget to drop your badge at the exit. We really appreciate what Jerica has done, providing these badges and having everything ready. Also, our volunteer, John Middleton, who does a tremendous job every time that we have a meeting with the organization of the event, with the attendees. Okay, we're going to take a 10-minute break, and then we're going to start our main presentation. Thank you.
It's Jack.
May I have your attention, please? We're about to start the presentation, so please go back to your seats so we can start in a few minutes. Thank you.
Can you hear me? Is that projecting?
I would like to make a brief introduction about our speaker for tonight. Jack Chosnek has a background in process safety. He started his career with Celanese. He spent over 23 years in the company, and then he started his consulting work with many different industries: petrochemical, chemical, oil and gas, many different companies, many different countries. He has been very active with the process safety field. He is part of the Mary O'Connor group in College Station. He is the current chair for the process safety group. He's also very active with the South Process Technology Conference. He is the chair since the inception of this conference. He has been very active in the 9 different events that we have had in the past, also with the process safety. And his presentation is going to be titled Chemical Engineering and, by the way, Process Safety. Please help me welcome Jack Chosnek.
Thank you, Carlos. Okay, it's my great pleasure to be here because I like being a chemical engineer. So I'm going to talk about the profession, chemical engineering, and by the way, process safety. Now, spoiler alert, the title may change during the presentation for this. I like being a chemical engineer, and I'm proud of it. We, essentially, chemical engineers, have contributed to civilization as we know it. If you think about almost any activity that we have today in the civilized world, chemical engineers are involved, directly involved. And if I can get this. Okay. This?
Are you trying to use laser?
The laser pointer?
Yeah, it's right.
Small technical difficulties. On the left, okay.
Or it's in the middle. Yeah, right.
Okay. So if you look at these are some, really not all the aspects of our modern world where chemical engineers are involved. And even in electronics, you couldn't even make semiconductors if it wasn't for chemical engineers. We do that. Other areas, the modern areas that didn't exist before, bioengineering and biomedical engineering. When they did the RISE, created the biomedical engineering faculty here, 60% of the initial faculty moved from chemical engineering to biomedical engineering. So we participate in all the good things, really, that we have in civilization. We create lots of stuff. We also leverage ourselves a lot. You know, I was working in Celanese. We had the largest world production of acetic acid was 1 billion pounds per hour, one reactor. And so I said, wow, you know, only a couple of chemical engineers are supporting this huge production. What other engineering can claim something like that? None, just chemical engineers. So here's a chemical engineer. Not really. Why? Because he's wearing a suit and a tie. Okay, he's also wearing a flimsy hard hat. Doesn't look like a real hard hat, right? For his age, you know, the chances are that it wouldn't be a man, it would be a woman. Because today, the young people, the young engineers, over 50% are women. So in that respect, we're also ahead of the other engineering disciplines. So we create a lot of stuff. We're responsible for a lot of good things in society. But, it's always a but, we're also responsible for some bad things in society. And that doesn't have to be. Who has heard of Bhopal, India? Okay, not everybody has heard of Bhopal, India. Bhopal is still the worst industrial accident in the history, recorded history of the world. Methyl isocyanate was responsible for that. That was just an intermediate for making an insecticide. Union Carbide had a plant in there in India, in a town called Bhopal. And there was a release of that methyl isocyanate. Water got into the tank and released a large vapor cloud that went into the neighboring city. And the same day that happened, there were already 2,000 people dead. Next day, 3,000 people. And by the end of 5 years, they had counted 30,000 people that had died from that incident directly. And there are probably 100,000 that still live with the scars from that thing. So this incident spurred a lot of the activity and later the legislation to get process safety off the ground. So some people are saying this was in, no, this was in 1984, right? That's what it says there? So some of the people here in the room said, I wasn't born there then. That's not my problem. Since then, probably all these problems have been resolved. And so we just need to look at the positive side of chemical engineering. But Philips, this is here in Pasadena, not too far away from here. And this was in 1989, and 23 people died in that, and terrible destruction. This kind of was what tipped the balance to get the OSHA 1910 legislation done, because they were been talking since Bhopal about this legislation, but when this happened in the United States, nobody could say, hey, that's only those people, even though it was an American company, it was in India. They don't know as much as we do. So this happened in 1989. By the way, the wife of the founder of the Mary Kay O'Connor Process Safety Center got killed in there. And so he took the insurance money and created or helped create this center that's called in the name of his wife, Mary Kay O'Connor. Mike O'Connor. He still works there at the center. So that's a, other destruction from a small plant, totally destroyed. So we have these events that have been milestones in the chemical industry. We had the Flixboro, 1974, and that kind of helped create management of change. That Flixboro was mainly because of management of change or mismanagement of change. Then we had, in 1975, PHAs were formally, especially the HAZOP methodology. ICI is the one that came up with that, 1975. 1984, we have Bhopal. So we had been doing PHAs for a while when Bhopal happened. Then Phillips in 1989. In 1992, finally the standards came, the OSHA 1910 standards came up. Then we had in 2005 the BP in Texas City, and 2010 the BP Deepwater Horizon. That again, I kinds of milestones, and first of all, notice that a lot of this stuff, except for Bhopal and the other one in India, happened here in our neighborhood, here in the Gulf Coast. So lots of industry here, and the Houston Chronicle never forgets to mention that the chemical industry is causing all these problems and death and all that type of stuff. So this year, I'll just mention that now, that this event cost BP $50 billion, billion with a B. No other company could have survived something like that. The previous incident, which people thought, well, that's really expensive. They calculate that cost $20 billion because they had to fix the same problem that they had all over the world, and that cost that money. This $50 billion is more direct cost to the company. Nobody will insure that company today. Actually, we're talking about that today. No other company in the world could have survived. Maybe ExxonMobil could have survived that type of event. So if you look at what we do as chemical engineers, and this is Flixboro, that event killed 29 people, again, because of mismanaged change. It was only 29 because it was at night, and the 200 people in the administration building that got destroyed were not there because it was at night. So got lucky in that respect. By the way, a lot of this stuff is in YouTube. You can search for that and look videos of this. They're very educational. Okay, so what's our function as chemical engineers? We design, operate, and maintain plants while obtaining optimal economic returns. Is that what we all learn in school? Right? Yes, that's the kind of, it's drilled. This is what we do. But if you have an incident, like any of these incidents, all your economic optimization goes out the window. There's no way that you're going to recover 50 billion or 20 billion, or losing your company like Union Carbide eventually disappeared in there. Just last week was an announcement that Eastman Kodak finally got back on stream. They had the two explosions 3 months ago. And they are calculating, that's their figures, that's going to cost them between $50 and $100 million. Okay. Where is your economic optimization when you do something like that? All your design, you said, oh, this plant will last 30 years. We do the calculations for 10 years, right? But it will last at least 30. But if you have an event like this, all your design goes out the window. It's not justified anymore. So, economic optimization. So, therefore, our task should be to design, operate, and maintain plants in an ethical and safe manner while obtaining optimal economic returns. We still want to make economic returns because that's good for society. All the things that we create are good for society. We still need to do it in an economic way. Can we do that and still make it safe and ethically? Yes, we can. Now, why did I put the word ethically there? Because that's very important. For those of you that are professional engineers, you know that ethics is a required 1 hour a year that you have to take. Why is that? Because you can make decisions that are going to get you safe but may not be ethical. One of them is build a plant in some other country where people don't care about the regulations or safety. So that's very unethical, right? So after having said that, we can do this by the way. We have to have chemical engineering and process safety. It has to be there, otherwise we're not meeting the objective of the profession if we don't do that. Okay, process safety is already required now for departments that want an accreditation, national accreditation. You have to now teach at least 1 credit of process safety. It's essential. More and more companies are realize that they need to have process safety and are doing it. But it's not enough. As I said, we just 3 months ago, we had a very large incident, and almost every week we hear about other incidents where people get killed, and of course the economics then go out the window. So the curriculum now in universities that departments that want to be accredited, because not everybody is accredited, you have to have process safety. So what is process safety? Is it a management system, a set of principles? Most people know it's a set of principles, it's some regulation, but it's actually both. So this is the way that CCPS, everybody knows what CCPS is. Anybody does not know what CCPS, don't be ashamed to say no. Okay, so everybody knows what is the Center for Chemical Process Safety of AICHE. So they develop all the materials for process safety, most of them. So this is the way that they describe process safety. It's a house or plant or whatever with a roof that's supported by pillars, and it has a foundation or various foundations. And I'll talk only about the foundations. The commit to process safety, you want to do it. Then you need to understand the hazards and risks that your designs and your plants have. Once you understand what are the risks and hazards, then you have to manage that risk and learn from experience. And on committing to process safety, what you're committing is also to have process safety competency. And that's one of the things that we have seen that's missing in many of these incidents, that we don't have competent people doing process safety. We don't have competent people doing a lot of designs. They're being rushed, and they're just being done for the economics. So having lots of companies are doing process safety. We have already, this year actually is 25 years since OSHA 1910-119 came on stream. 1992, right? 25 years anniversary. So after all this activity is, the question is, why do we keep having so many process incidents? Hey, we have process safety 25 years. We have had that, and we still continue to have incidents. So let's talk a little bit about another way of looking at process safety. This is, again, from CCPS Layer of Protection book, LOPA. And this is the way that the world of chemical engineers or a plant is presented. We have the process, which is the part that contains the hazards, right? Chemicals, high pressure, high temperature, those are the hazards. We design to produce, most of the time, materials that have inherent properties that are hazardous. Toxicity, flammability, high pressure, high temperature. So those things can do harm. So the way that we design is we have the process and we put some basic controls. Process alarms, operators. Then we have preventive safeguards, which is your critical alarms, automatic action or shutdown system or safety instrumented systems, and physical protection, PSVs and things like that keep the process contained. If in spite of that, we if in spite of that we lose containment, then we set up mitigation safeguards. Mitigation safeguards may be your dikes, water curtains, fire protection. So out here, we have the consequences. So this is what we do. So in spite of all this, and we're doing very well on these things, we still get incidents. So why are we not looking at our designs? Why do we need to have all these things if we can do a good design and prevent accidents? What we're doing essentially is we design and then we band-aid, because there are pressures. You can spend too much time designing, and this is the way we learn in school. This is when you set up. Most of us can just sit with a sketch pad and say, this is the way a distillation column works, and a pump, and you connect those lines, and here you put a pressure indicator and a pump and this, and you put a PSV, and hey, we're done. Afterwards, somebody has to go and do a process hazard analysis and said, oh, this really won't work if our pressure goes up. So we need to put a Band-Aid. I call them Band-Aids. It's a, you know, if we come to think, oh, we need instrumentation to keep the process safe. So we keep doing that. We don't have enough time to, or the knowledge, or the know-how to design without Band-Aids, because we were never taught how to design properly. We were taught to design for things that work. This is normal operation. We want a plant that will produce 100 million pounds or tons a year, and this is the way we're going to design it, and it's going to work. Because you always have normal operation, right? So here's our chemical engineer saying, hey, if we design it, it's going to work. I think the attitude is, that's why he chose this photograph. Not because he's got a positive attitude. And I like that. We need to have positive attitudes. I think chemical engineers do have positive attitudes for the most part. But we already learned that just if we design it with all your self-confidence and all that, it may not work. There's a good chance that you're going to have some incidents. So we need to learn, first of all, that things do fail. That is not just a steady state, and small deviations that we use process control in our design to get control of, and we're okay. Things do fail. And we have failures of humans, because we still need humans to operate and design and maintain these things. And we need to have, we have failures of materials. You know, that no matter how good the quality control is, still will creep in there. So we don't learn, when we learn design, what's the impact on the process if there is a failure. Did anybody learn that in school? Not have failures? Just getting off set point, besides getting off the process control band. I haven't seen that people learn that. They said, this is the way things work, so go design. So we don't design for things that fail. So a large project that I was involved in, this $3 billion project plus. And when designing, it's a large project, complex. The last column on the long purification train was the engineer said, that's going to maximum have 35 pounds. And so this is exotic materials, so we need to order that, so let's order a 50-pound tower in there. That should do it. So it got ordered. It's a year delivery for that. Once they start looking at the process hazard analysis, they said, oh, the pressure really can get to 50, maybe 55, could be even 60 pounds if this happens, if this fails. So what do you do? Hey, the tower was ordered 8 months ago. By the time we found this, we got to this design. So what do you do? The difference between, one of the engineers has said, hey, if we get this combination of raw materials, the quality of the raw materials, you know, we may get sometimes 50 pounds. You know, it's a combination of, you know, the phase of the moon and, getting people failing their quality and things like that. But it turned out it was true. It didn't take really the phases of the moon. It really took much less than that, just a piece of equipment failing. So what do you do at that stage? The difference in cost for a 50 and a 70-pound tower was going to be maybe $300,000. So how much it costs to Band-Aid this or that tower, which if that tower went, the whole process would go down and would be very expensive. So it's another $2.5 million just to fix the problem. Okay? So are we doing our job when we do things like that? So if we have these failures, what can we do about it? We need to have a resilient design. Means that design that can work even if you have failures in the design. Even if people make mistakes, you say, oh, that operator, he's an idiot. So we'll hire people that are not idiots, and they'll never make mistakes. So this will never happen. No, we need to have designs that if somebody makes a mistake, the design still can safely take it. So one of the ways to do it, and this is not advocated as the way to do it, because this is not the way to do it every opportunity. It's inherently safer design. And notice that this is safer, it's not safe design. Means a little bit more safe than usual because you are building in a certain way. This has been advocated by one of the greats of process safety, Trevor Kletz. Anybody heard about Trevor Kletz? Yeah, a few people. So it has been kind of put into some principles which change, but typically minimize, substitute, moderate, and simplify in terms of minimize quantities of materials that are hazardous, substitute the less hazardous material, moderate run reactions at lower temperatures or milder conditions, and simplify. Complexity is the enemy of safety. So keep it simple. Don't get too sophisticated. Which, when we are doing optimization of a process, if you get those that have done pinch points and all that type of stuff, if you move away from your pinch point, your optimization falls apart. So if you need to make changes afterwards, is your design resilient enough to take it? So this is an example that of inherently safer design. The same methyl isocyanide that was in Bhopal, the same intermediate. So what the DuPont used it, substitute and minimize. They changed the chemistry, and MIC was used immediately in the reactor. So what did that do? You didn't have to have a tank with MIC. So if you didn't have a tank with MIC, Bhopal couldn't have happened, period. At most, you have a few pounds on a pipe of MIC to do that. So have to change your thinking. And I said, this is not the solution to do every design. You can do inherently safer design. But we need to change our thinking that you don't do things the traditional way. You need to think of what are the consequences of these hazardous materials that we deal with, every day. So when we do the designs, it's not steady state. There are failures, human failures, and equipment failures, material failures. Another example, and by the way, Vic Edwards and I wrote a couple of papers on inherently safer design, and so these are taken from that paper. This is one of the explosions that happened again in our neighborhood. This was in Seadrift, Texas. What was done? This was done in a two-column process. I'll talk about that. What happened is that this process of purifying ethylene oxide is really a nasty chemical. It has a flammability range from 3 to 100%. It polymerizes, it decomposes, and it's a carcinogen on top of that. It's very reactive, so it was used in hospitals for sterilization until they found this was a carcinogen, but it was a great sterilization agent. So this is the typical traditional way to design. We want to purify something. We put the column to remove the heavy ends. Heavy ends go out there. Then we take our product and then remove the light ends, and this is the pure product. So this is the way that was being done. Union Carbide did it. We at Celanese did it the same way. This is what we learn in school. Heavy ends, light ends, you're pure. So what happened is that you have pure ethylene oxide in here, and this is a thermosiphon reboiler. And Union Carbide, the pressure started going up. They found out that the water, the cooling water, was turned off in the overhead receiver. That's why the pressure was going up. So they went, fixed that. In the meanwhile, all the tower dumped was full of ethylene oxide, and they couldn't restart the reboiler, thermosiphon reboiler. Why? Because you can't restart thermosiphon reboilers if your liquid level is above the return of the thing. Of course, the operators didn't know that. Probably the chemical engineers didn't know that, because that's not something that you learn in school. So the operators, being very smart, say, oh, it's not starting because we just need more temperature. So they connected higher pressure steam to that, and that's when it blew up. Okay? So we said, hey, we have the same process. We can't let that happen. I mean, it's going to happen, because you have pure ethylene oxide and you have temperature. Fortunately, it was a smart guy in our group. It wasn't me. And he came up. This is the Seadrift explosion. One person got killed in that explosion. Again, luckily, because it was at night. There weren't too many people present. They say that the boom was heard 40 miles away. The plant was destroyed. Union Carbide again. And by the way, these companies that get involved in these big incidents or a lot of small incidents, they disappear. Union Carbide doesn't exist anymore. DuPont, that used to be a great safety company, they started in the last few years kind of going down in terms of safety. They have been bought by Dow, and Dow is going to dismember that. So name DuPont may disappear at some point in time. So this guy came with the idea of why won't we do it in one column? What happens here? You have your material, you take light ends there, you take your heavy ends there, and then you take your product in the middle. So why is this safer? Because your reboiler here is seeing only mostly water. So it's never going to see concentrated ethylene oxide. Concentrated ethylene oxide is here. So even if you stop the process and the tower dumps, you still are going to have dilute ethylene oxide. So this is inherently safer because you have removed the combination of pure ethylene oxide and heat in there. So that's inherently safer. So we need to think that way. Now, why did we design from the beginning? Why didn't we do this from the beginning? One tower is, I would think, cheaper than two towers, right? You have to add all these pumps and reboiler for the other one and all that. Why don't we do it? Because this is not the way that we learn. This is already too complicated. It takes longer to design something like this. It's not that the technology is not known. It is unknown. We know the technology. That's not the way we learn. Do it this way, this way. You do this, this is what you do, this is what you do. Don't think too much. So this is what we need to teach, that don't take the first solution as the solution for your design. Think a little bit, is it hazardous? Can we have failures? Can we do it better? So, in short, or maybe it's been too long, we can't separate process safety from chemical engineering. I mean, it's the same process. You just need to take into consideration things that don't work as ideal. So I'm going to change the title again of the presentation and call it Chemical Engineering and its unit operations. And one of those unit operations is process safety. The same way that we do heat transfer, mass transfer, fluid flow, we need to be doing from the beginning process safety. Put that in our design. When we design a heat exchanger, we don't say, hey, just design it for steady state. Don't worry about startup or shutdown. It'll be okay. Will that work? No. Do we do it? No. We think, well, what's going to happen when we start up and we shut down with that heat exchanger. So we need to build that into design. So we need to do the same thing with process safety. We don't need to, we can't wait until the design is finished or have finished, do a PHA and say, okay, these were the problems that we didn't fix from the beginning, let's fix them now. So this is what I'm advocating, that we need to teach in our universities, in our schools, in our plants, because some people already have missed this opportunity, that part of chemical engineering is process safety. And that's all what I want to say. Thank you. Any questions, comments? No? No comments? This will work?
We'd like to open up the floor for some questions.
Larry?
Hi, Jack. Yeah, yeah. Hey, a lot of that subject's dear to my heart, and I've been involved in a number of close calls that were a result of problems in the design, problems in the organization, and all these things are just like you say, being in a hurry to get things done. Maybe you don't have enough resources. Maybe the design, you didn't take time to go through it, and you end up with something that gets somebody hurt or killed. And one of those things that you touched on it, but I'd like to emphasize, is the fact that when you're going through these designs, you have got to put yourself in the position of the operating people, because they don't make mistakes on purpose. They do it because they're overburdened. It's too complex. They can't figure it out quickly. They do something they did with unintended consequences because someone in the design didn't take that into account, like how you start it up, how do you fill the column up ahead of time? Is it going to be done safely? Or do you put a bypass in? What if they leave the bypass open? All those things end up in resulting in a major disaster. DuPont had that problem with their neoprene plant, where somebody in startup put in a bypass because they didn't have a fast way to get the material in there. Well, it wasn't on the P&ID, and nobody took that into account when they look at the downstream vessels. And in the downstream vessels, one of the startups, they left that bypasses open, and when I guess it was a shutdown. When they shut down, there was not supposed to be any butadiene in the end tanks, and so they never designed for that possibility. Well, this bypass is left open, and they're shut down. Nobody's even watching it, and the butadiene was flowing into that last tank, and there was insufficient instrumentation there to warn them of what was going on until they started seeing foam coming out of the relief valve. Well, it resulted in a runaway reaction that blew up the tank and killed 2 people. So, just a simple little thing like a bypass put in on the startup. These are things that have to be anticipated and gone over and over again on the beginning to be sure that if something like that is done, that is taken into account so that any possible result can be monitored and avoided.
Okay. You're right that we can't expect operators to know some things if we don't know those things. So we can't expect other people that we tell them go and operate this too. You want to ask a question?
Yeah. I was curious. You were talking about the inherently safer design being done at the university levels, and I'm wondering if there might be another way, which would be through corporate design standards, that when an operating company sends a bid out to an E&C firm, that they put that I'm wondering if the operating companies might be in a better position to anticipate some of these problems than a university would, and that's where these guidelines need to be if you want to avoid these safety problems.
But putting standards doesn't educate people. It forces you to do certain things. But you can put in a standard everything. You need to have competent people that can apply that standard. And if you may put the best standards in the world, but if you don't have people that can know how to apply those standards, the standards is not going to help you, period. So if you have designed equipment badly, you already got it. What do you do? It has problems already built into the design. What's your corporate standard going to do? Where are you going to get your equipment designed? You can ask, I want it to be inherently safer. Okay, ask. Who's going to do that job? Who knows how to do that job? You have to train chemical engineers to think. I said that's not the panacea, inherently safer design. It's just a way of thinking, We have hazardous materials, big quantities. How do we reduce those quantities? Can we make it work with lower quantities? Can we make it work at lower pressures or temperatures or things like that? So, but it has to come from the beginning. We need to get educated on how to design safely. Okay. Any other comments, questions? Oh, who has the microphone?
I have the microphone.
Okay, so ask a question.
I got the microphone. So, you know, there is another practice we have in industry-wide that is called risk assessment, risk management, right? We assign probabilities to something going wrong, and we figure out what is the quantitative risk, and then we do this probability you know, loss assessment, and we say, okay, this is going to save us, and we take that as saying, okay, it's fine to go ahead. So any thoughts on that? This is basically something, you know, all of these low power, you know, approach and all of this that's what we do in PHA. We sit down and we start to assign probability. We identify a risk, and something can blow up, people can die, but we still go ahead and assign probabilities, and we say, okay, this control scheme here will save us.
The thing is that why do you have to do all those things? You know, why didn't you design from the beginning so your probabilities are really, really low in your design? So yes, you determine that after the fact. I got stuck with this design. Now I have to make sure that it works safely. Why? Why not make it safe from the beginning? So yeah, we have very good techniques to manage risk, but we're still getting into all these incidents. Why is that? First of all, because some designs are extremely difficult to correct. All the traps, all the flaws that you have. Second is because in order to analyze those risks and come up with the correct, you need to have experienced people that say, oh, this can happen. This can happen. But you don't learn those things at the university of what can happen. So that's why we have incidents, because we don't fix everything else.
Jack, we would like to thank you.
Okay, let me just one last thought.
Okay, thank you so much for Jack for the presentation.
Thank you.
Thank you, Jack. Okay, I would like to appreciate your attendance today. This is a really great meeting. I'm looking forward to see you on February the 1st. Please don't forget to drop the badges before you leave. Thank you so much.
I'll drop the microphone here so you can take it home.